Hello viewers, today is for Venn diagrams. The last time we were able to look at introduction to set, where we looked at different aspects of set such as the definition of set and then the concept and conception. We looked at the subset, we looked at the superset, we looked at complement of a set, we looked at cardinality of a set, we looked at the what is it called, union of set as well as intersection of set. So today is about Venn diagrams, and Venn diagram is nothing other than the diagrammatic representation of the members of a set. So we have a question here with which we are going to deal with that, and I'll be using this question to explain in-depthly what each aspect of the set represents. So the question says, given that the universal set A equals set of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and set A gotten from the universal set has these members 2, 4, 6, and 8, while set B contains the member 2, 3, and 8. So the question says, represent the given information on a Venn diagram. That's what the question says. So I've started the beginning aspect of the solution, and that's just rewriting exactly what we have here so that we'll see what to do from there. Now, for the universal set, it's been taken down, and these are set A and these are what? Set B. So I'm going to be showing you how a Venn diagram looks like and what are the different aspects of the Venn diagram. Now, the Venn diagram mostly looks something like this. We are going to have a circle for set A, and we are going to have another circle for set B. So that is what we have. And then somewhere around there, we are going to see the universal set. That tells us that every member of set A, 2, 4, 6, and 8 are supposed to go into the circle for set A. Every member of set B, 2, 3, and 8, they are supposed to go into the circle of what? B. Now this rectangular shape represents the aspect for the universal set. It means that everything in this universal set must be contained in this rectangular shape. Now let us see how we are going to have those things. Now let's say I have something like this. I just have A like this. This is circled for A, and every member of set A are supposed to go in there. So I'm supposed to have 2, 4, 6, 8 in the circle. So I can just distribute them anywhere. 2, 4, 6, and what? 8. So these are the members of set A. Then we are going to have members of set B as given in the question as well. So the members of set B are 2, 3, and 8. So the members are 2, 3, and what? 8, just to distribute them. Now, normally, if we look at A and B, they have some elements in common. For example, 2 is in set A, it's also in set B. 8 is in set A, it's also in what? Set B. So when two sets have elements that are common, we say that is what? In the intersection of those two sets. So we are going to be starting with the what? With the intersection of these two sets. And the intersection of these two sets is 2 contain the element 2 and 8. So we are going to start with, look at what, when we now draw this circle, now this is circle for A and this is circle for B, but circle for A and B, they have something in common, which is this middle part that connects them. So that middle part is the one that's going to contain the intersection of these two sets. So it means that we have entered 2 and we have entered the element 8. So what are the elements that are remaining in A now, circle A? It's just what? 2 and 4. So elements that are remaining are what? Just what? 4 and 6. So these 4 and 6 can just be distributed in A anywhere. So that tells you that in circle A we have been able to enter 2, 4, 6, and 8 as contained in this circle here. Then for circle B, 2 and 8 have already been entered based on what they have in common with A. So what the only element that has not been entered for B is what? Is 3. So that element goes in here as 3. So that is how the distribution is being done for Venn diagrams. So the next thing to do now is that these are elements that are found in set A and B together. So it means that if I'm going to list out all of these elements, that's the union of what? A and B, merging of all the elements in A and B. If you look at our last video, go back to watch our last video, you'll see that that is what we're going to have. There are some elements in the universal set, as given in the universal set, but they are not found in what? Set A and B. But they are still in a what? the universal set. So what do we do with those elements? For example, we have 1 in the universal set, but it has not been taken down here. So that 1 can be entered anywhere as long as it's in the universal set. It doesn't go outside the rectangle for the universal set. There is 2 here, and 2 has already been entered. No need. There is 3 here. 3 has already been entered. There is 4 here, but also entered. There is 5 here. So, but 5 has not been entered here. So we can put 5 either here, or anywhere in the rectangle as long as it doesn't fall in the circle. So our 5 can go here. Afterward, we have 6. 6 is there. We have 7. 7 is not in there, so we can put our 7 here. We have 8 in the universal set. 8 is already entered. We have 9. 9 is not entered yet, so we can put our what? 9 here. And then finally we have 10, and 10 is not being entered yet. So we are going to have our 10 here. So based on these things that we have here, you can see how the circle A comes in, or you can see how the circle B comes in, and how each of them, all the elements of the universal set have been distributed in the Venn diagram. So this is the introductory aspects to Venn diagram and how things are being distributed. So let me use the normal English, the everyday English, common English they use in this. All the elements in A are 2, 4, 6, and 8. But elements in A only are 4 and 6. A only means that they are in A, but they are not in what? B. In A, but not in B. That's A only. Then we have elements in B generally. They are 2, 3, and 8. Then we have elements in B only. Element in B only is just what? 3. Then we have elements in A intersection B. A intersection B. The elements in A intersection B are what? 2 and 8. Because those are the ones that are common. So let me see if I can use a set builder notation to bring out each section or different section of this Venn diagram. Now, of course, we have seen elements in A, they are this. We have seen elements in B, they are this. Then we have elements in A and B common. That's A intersection B. So what are the elements that are common to A and B? They are 2 and 8. So it's going to be written like this: 2, 8. Then we have elements that are in A only, but they are not in B. So this is the representation for that. A intersection B prime. A intersection B prime. What are the elements? They are in A, but they are not in B. They are 4, 6. Those are the only 2 elements. So another way they normally write is they say what element is in A only. That's everyday English for it. A only. Then element in B only. They are in B, but they are not in A. So that is A prime intersection B. A prime intersection B is this. And it's just what? 3. So we're going to have our 3 here. That's what we have there. Now, which other one? Now there are elements that are in the universal set, but they don't fall in A and they don't fall in B. So what is that? So that's going to be, this is the way to write that. A union B. When we talk about A union B, they are the merging of the elements in A and B together. But then, after you have merged the elements in A and the elements in B together, they are in the universal set, but they are not in this union. So if they are not in this union, yet they are in the universal set, that's A union B, everything was prime. And that is equals to, so what are those elements? We have 1, we have 5, we have 9, and then, we have 7, which I skipped, and then we have 10. So these are the elements that are in the universal set, but they are not in the union of what? A and B. So these are the different aspects of the Venn diagram, and we have shown them out. So I believe